So what is conditional probability? So, so you have understood, P of A, P of P, P of A intersection B, and so on, right? Now, if you are given something and you want to calculate the probability, right? If you know some information prior, beforehand, and you want to calculate the probability of something by knowing that information. So basically, you're conditioning on, you have some condition, that, okay, I know this. And then what will be a probability of something, right? So, for example, if I, go back to my tossing of coin example, right? If I go back to the, yeah, tossing, right? So, if I know that uh, the first coin is basically giving me, if I know that out of the two coins, the first coin is heads for me, okay? Then what will be the probability that the second to find? So in this example, let's consider I want to calculate the probability that the second coin gives heads, given that my first coin is head, right? To calculate. So if you see from this sample space, which are the examples, which are the events that shows that first coin is head. So this is the first coin is head, and again this one. These two are the only uh, events uh, which shows that first coin is heads. Now we want to calculate what are the chances that my second coin will also show heads. So that will basically, so your sample space is now reduced to only these two values. Your sample space is now only, this is the sample space, right? Now between these two, you want to calculate what is the probability also shows heads. So that is basically only this is your favorable outcome. So 1 by 2. Out of 2, you have only one favorable outcome. So you see, your probability has now increased. Your probability has been refined. Your probability has changed because you are adding one condition to it, right? So previously, the probability of head was 1 by 4. Now, since you know that the first coin is head and you want to calculate what is the probability of the second coin, this probability has increased, right? So this is a very, very powerful tool. And yeah, so we'll see how it is used in future. Okay. So, okay. Yeah, for by P of P, right? So again, I will explain through this example again. So P of H2 given H1 is basically P of H1 intersection H2 divided by uh, H1, right? So you have to calculate what is the probability that both are heads. So H1 intersection H2 is head. What is the probability? That is 1 by 4. If you look at the original sample space. So now we will go to the original sample space. Okay. So what is the original sample space? HH, HT, TH, TT. Okay. So now what is the probability that both are heads? That is 1 by 4. You know. So in these two are the favorable outcomes, right? 2 out of 2 by 4. So this will basically give you half. Again, you see that is the same thing that we are getting. So explain the intuition, like why the formula is this, and this part shows that the formula actually works. The second part shows that okay, the formula now works, right? So is there any question now on this conditional probability? All right. So yeah, one comment on this is that so if P of H2 given H1 is uh, basically H2 if H1 and H2 are independent. So this is the condition for independence, right? So what does it mean? That you're tossing two coins. So the result of one coin is not dependent on the result of the second coin, right? Because you're tossing different coins individually, considering that both coins are fair, and one then the tossing of one of the probability that you get heads on the second coin is simply P of H2. And what is the probability that you get head on the second coin? Yeah, right? So again, all these things, this example can, is explaining all the things that I have, like the example has explained what are, as well as, conditional probability and, uh, you know, of events and so on, right? So, yeah, any questions? And again, if two events are independent, then P of H1 intersection H2 should be equal to P of H1, right? So again, so someone was asking like where to use multiplication, Kavita. So the dependent events, if you want to calculate what is the probability that both the event occurs, then you have to say that okay, P of what is the probability that I get head on the first coin? That is half. What is the probability that I get head on the second coin? That is also half. You get 1 by 4, right? Somehow in the notepad. Mm, Okay, I think I should move on to the slide. All right. So I think, yeah, that is it. Okay, so someone is asking P H1 equals P H1 given H2 is H1. Yeah, so for for two events to be independent, you need to have basically equals to P of A and P of B given A equals to P of B. You need to two events are independent. Okay. Yeah. So basically, P of H1 given H2 should also be equals to P of H1. Okay. So this step, yeah. So I'm saying, yeah. What I'm this condition has to be satisfied for H1 and H2 to be independent, right?